Hello and welcome to this video. As we had discussed in last video, we will go through Bisect, which is array bisection algorithm of Python standard library, and we will look at an example. Also, at the end, I will show you my website where you can ask questions related to Python because YouTube comment box is not really suitable for discussion code. So without further ado, let's get started through this exemplified video. This module provides support for maintaining a list in sorted order without having to sort the list after each insertion. For long lists of items with expensive comparison operations, this can be an improvement over linear searches or frequent to sort. This module is called Bisect because it uses a basic bisection algorithm to do its work. Unlike other bisection tools that search for a specific value, the functions in this module are designed to locate an insertion point. Accordingly, the functions never call an equality overloaded operator, that is, method to determine whether a value has been found. Instead, the function calls only call the less than method and will return an insertion point between values in an array. Now we have a note here. The functions in this module are not thread safe. If multiple threads concurrently use bisect functions on the same sequence, this may result in undefined behavior. Likewise, if the provided sequence is mutated by a different thread when a bisect function is operating on it, the result is undefined. For example, using insert underscore left on the same list from multiple threads may result in the list becoming unsorted. The following functions are provided. So we have the function bisect underscore left from the module bisect. Arguments are a, x, low is 0, high is length of a, and then we have key. Locate the insertion point for x in A. So A is a list, x is a value. To maintain sorted order, the parameters low and high may be used to specify a subset of the list which should be considered. By default, the entire list is used. If x is already present in A, the insertion point will be before to the left of any existing entries. The return value is suitable for use as the first parameter to list.insert, assuming that A is already sorted. The return insertion point IP partitions the array in A into two slices such that all elements less than X or element in A low colon IP is true. That is, all the elements which are less than X will come to the left hand side of the insertion point. And for the left slice, and all element greater than X for element in AIP colon I is true for the right slice. Key specifies the key function of one argument that is used to extract the comparison key from each element. In the array to support searching complex records, the key function is not applied to the X value. The key is none. If key is none, the elements are compared directly and no key function is called. Then we have bisect right and bisect. So signatures are same to bisect left. Similar to bisect left, but returns an insertion point which comes after to the right of any existing entries of X in A. The return insertion point IP partitions the array A into two slices such that all elements less than equal to, now the difference here is equal to compared to bisect underscore left for element in A low colon insertion point is true for the left slices and all elements greater than X. So it was greater than equal to. For element in A IP colon 5 is true for the right slice. So that is what bisect left and bisect right are there, and bisect also. Now we have insert left, where A is there, the list X is the value, and other we have already discussed. Insert X in A in sorted order. This function first runs bisect left to locate an insertion point. Next, it runs the insert method on A to insert X at the appropriate position to maintain sorted order. To support inserting records in table, the key function, if any, is applied to X for the search step, but not for the insertion step. Keep in mind that the O login search is dominated by the slow ON insertion step. Then we have insert right or insert, similar to insert left, but inserting x in A after any existing entries of x. This function first runs bisect right to locate an insertion point. Next, it runs insert method on A to insert x at appropriate position to maintain sort order. The key functions are same and note on complexity is same. Performance notes. When writing time-sensitive code, use bisect and insert keeping these thoughts in mind. Bisection is effective for searching range of values. For locating specific values, dictionaries are more performant. The insert functions are OM because the logarithmic search step is dominated by the linear time insertion step. The search functions are stateless and discard key function results after they are used. Consequently, if the search functions are used in a loop, the key function may be called again and again on the same array element. If the key function isn't fast, consider wrapping it with functools.cache to avoid duplicate computation. Alternatively, consider searching an array of pre-computed keys to locate the insertion point. As shown in the example sections, you will see. Sorted collections is a high-performance module that uses Bisect to manage sorted collections of data. The sorted collection recipe uses Bisect to build a full-featured collection class that straightforward search methods and supports for a key function. The keys are pre-computed to save unnecessary calls to the key function during searches. So let's, okay, it is outside, okay. So you can go ahead and check these links. Perhaps later I can come and maybe next video I'll show you what is all these. So sorted collections, if you see, we will have Python sorted collections here. So you can install using tip. It's a third-party library. So we will not discuss it. Then we are searching sorted list. The above bisect functions are useful for finding insertion points but can be tricky or awkward to use for common searching tasks. The following 5 functions show how to transform them into standard lookups for sorted list. So we have index a comma x, locate the leftmost value exactly equal to x. So we first call bisect underscore left on x and we get an insertion point. Now if I is not equal to length of a and that is it is not the last element and ai is equal to x, return I, else return value error. Then we have find less than, find rightmost value less than x. We call bisect left on this. And if I is a value, then we return ai minus 1. So it will give the rightmost value less than x. Similarly, we have find less than equal to, find rightmost value less than or equal to x. So it perform bisect right. And find greater than, find leftmost value greater than x. We perform bisect right on x. And if I is not equal to length, then we return ai. Then find greater than equal to, find the leftmost item greater than or equal to x. We simply call bisect left. And if I is not equal to length, we return ai. Now we have some examples. The bisect function can be useful for numeric table lookup. This example uses bisect to look up a letter grade for an exam score, say based on the set of ordered numeric grade points. 19 and up is A, 80 to 89 is B, and so on. So we want to grade and we bisect this on the basis of score. So bisect by default will be bisect right. Okay. So the scores are F, D, C, B, A, and we then call grade score for scoring 33, 99, 77, 70, 89, 90, and 100. And we get the grades as F, A, C, C, D, A. The bisect and insert functions also work with list of tuples. The key argument can serve to extract the field used for ordering records in a table. So we have imported num table, attribute getter, bisect, insert, and pretty print. And then we have a name tuple, movie, name, release, director. So new movie is Jaws 1975, Spielberg, Titanic 1997, and Cameron, and so on. So by year, we get the attribute released and we sort by year. So the key is supplied by year, that is the attribute released. and then you bisect this. So if you bisect this, we call bisect on this movies. Okay, 1960 key is by year. So our list is movies. That is this list. X is 1960, and comparison function is by year. So the bisect will give the insertion point, and that would be 1963 year, because that is the smallest value on the left side. All others are greater than that. Insert a movie while maintaining a sort order. So you do insert, romance is inserted, and when you print the movies, so you see 1970 is placed between 1963 and 1975. If the key function is expensive, it is possible to avoid repeated functions calls by searching a list of pre-computed keys to find the index of a record. So suppose we have this list of tuples, red 5, blue 1, yellow 8, and black 0. And we sort this where key is equal to lambda, r is equal to r1. So these numeric values are used for sorting, and keys are r1 for r in data. So again, the indexes are this, and then we bisect left. We give keys and 0, then we get black. If we give 1, then we get blue. If we give 5, then we get red, and for 8, we get yellow. So that was the module and its example. I have also prepared one example here. So let me comment this out, and so that we can see one chunk at a time. Oops. So we have numbers 10, 20, 20, 20, 35, 40, 55, 60, 80. This is a sorted list, and I print the numbers. Then we bisect left on this. So A is numbers and X is our 20. So we will get the insert position of 20 in this case. That is the index. It returns the leftmost occurrence. Okay. And we will see both these sides of bisection point. So left two bisections will be in this one, and numbers greater than the index will be here. So let's run the shell, and we say Python space this was bisect. Oops, I did not save. So we run this, and you see it gives us the leftmost point. That is, all the values on the left side are less than 20. Okay. Then we comment this out. Comment this out. Okay, so we still need numbers, right? We still need numbers, so we put this here, and we comment till here. Numbers is what we need. So okay, so we put this here, and we comment this out. So we will have bisect right, and then we comment this out. Okay, that should do. And then we have bisect right call, and we run Python space bisect one, but right. So you see bisect right gives us the insertion point after the 20. So it is less than equal to, as we studied. Now we comment this out, and we do bisect. Okay, bisect is an alias of bisect right. So it will give us the same output. Okay. So we are getting the position 4. So this is 1, 0, 1, 2, 3, and this pipe is 4. Okay. So we get this out, and now we will search for if an item exists. Okay. So we let X is equal to 35, and we bisect left. So we'll get an insertion point which will be after 35, right? So 35 we will get bisect left will give us here at position 4, right? Less than 35. Now, if I is not equal to len numbers, which won't be the case, and numbers si is equal to x found at index I, okay? And otherwise it's not found, but it will be found because 35 is there. Then we have 42. 42 is not there, so 42 is not found and would be inserted at position x. So this should be position 5, right? After 35, position 5. 0, 1, 2, 3, 4, position 5. Now 42 was not found, would be inserted at index 6. Why it is saying 6? So 42, right? So 42 will be inserted at index 6. Okay, I did not count for 0. 0, 1, 2, 3, 4, 5. And then at the 6th index, it would be inserted. I did not account for 40 for 42. My bad. And similarly, we have insert, which will do insert left. So, okay, all right. So we have number, we make a copy of numbers.list, and to this list, we insert 20. So this is insert left. So 20 will be inserted before existing 20s, right? So you can't see which 20 went where in this one. So let me insert 34. So 34 will go left of 35. Okay. Now, similarly, you have insert right, so you can play with all these. I will put this file in a gist. Let me do that. So you can play with this example. Let me copy this and create a gist out of it. Gist.github.com, and I will call this bisect.md and paste the entire thing here. And we call this Python. And we put the triple dactyl. So the link to this gist will be in the description of the video, and you can enjoy playing this example. So with this, I will end this video here, and in the next video, we are going to look at array, which are efficient array of numeric values, which is after bisect. Okay, I have already read it, so you can see the colors and the ref also. So I'll take my leave here, and we will meet again after 4 days with another video on Python on arrays. Till then, keep learning, enjoy, and I'll say goodbye to you. I'll see you after 4 days. Till then, sayonara.